Number 19, y is less than or equal to x plus 7, and y is greater than or equal to negative 2x minus 1. Which point x and y is a solution to the given system of inequalities in the xy plane? Whenever you have a system of inequalities, you're going to end up with something that looks like it's either going to be, it could be a straight line, it also could be a dotted line. The difference is right here in the symbol. When it's less than or equal to or greater than or equal to, it's going to be straight, solid lines. When it is greater than or less than or greater than, it's going to be dashed or dotted lines, because it's showing that line is not part of it. It is not equal to as well. The equal to part is the line. So when you do a dashed line, it's showing the line is not part of the solution. It's also going to include shading. So if I have something like, let's say I have this dashed line, something like this, it's also going to be shaded on either one side or the other. And that shading shows you all the possible solutions that fit that inequality. All right, so I'm going to cover it now. There's two ways, I should say, before we get into this, there's two ways you can do this. You can type both of these into Desmos and see the shaded area that comes back, and then see which of these points goes into that. You absolutely can do that. I am going to show you how to shade this on your own. Once you know how to shade it on your own, you can do a sort of a rough, quick sketch of this and figure this out. Personally, I think it's a little faster than doing it in Desmos. And, you know, it's the SAT. We want you to do things as quickly as possible to give you the most time, so you're not left getting questions wrong because you ran out of time. We don't want that. So once I show you this method, it will be up to you which one you want to use. Both are going to give you the right answer. So again, of course, you can just type both of these into Desmos, and you're going to look for, you're going to get two lines. I'm not drawing this to scale. I'm just drawing two lines here. And you're going to be looking for, when you have these kind of problems, you're going to see two shaded areas. And then the solution is the place where they overlap. You're going to look for a point that's in that overlapping area. So that's the idea that we're going to do. Now let's get a little more precise here. So first, y is less than or equal to x plus 7. We're going to graph this just like a regular line at first, and then we're going to deal with the shading. So x plus 7. This 7, we're doing things in that y equals mx plus b format. B is the y-intercept, m is the slope. So here, 7 is my y-intercept. 1, 2, 3, 4, 5, 6, 7. And my slope is 1. So up 1, over 1, down 1, over 1. So it's kind of, that's not too bad. That's well, maybe not. Trying to give you a decent, there we go. So there's a decent line. Okay. And if you're just sketching this on a paper, you're still going to get this right answer. And if you're doing it like not to scale, but it's going to give you enough of an idea here, because that's what I did. I always take these tests myself before I try to explain them to others. And I did a quick little sketch and like, boom, there we go. So it doesn't have to be this perfectly drawn to scale. I'm just trying to make it very clear so everyone can see here. Okay, so there's my line. Now I need to know where to shade. Do I shade on this side or do I shade on that side? What I do is I pick a test point. 0, 0, if it is not on the line, is a great test point. You're going to plug 0 in for the x, 0 in for the y, and see, is it true? So there you would get 0 is less than or equal to 0 plus 7. 0 plus 7 is 7. Is 0 less than 7? Yes, it is. Shade this side. So that's my shaded area for that one. Now my other one, y is greater than or equal to negative 2x minus 1. Using our same mx plus b, negative 1 is my x-intercept. Negative 2 means it goes down 2, then to the right 1. There's my, why is this thing? It doesn't like me when I draw dots. I don't know why this whiteboard doesn't like it when you draw dots, but it doesn't. It's a glitch. Okay, so there's my little negative 2 slope. Goes down 2 to the right 1. That's that negative 2. Rise over run, negative 2 over 1. Okay, Now, where do I shade for this one? I'm going to use that same thing. I'm going to plug in 0, 0 because 0, 0 is not on that line. So 0 is greater than or equal to, again, using that original equation, -2 times 0 minus 1. -2 times 0 is 0. And then we have that minus 1. Is 0 greater than or equal to minus 1? Yes, it is. So we shade the part of the graph where 0, 0 is. If I had got a statement that was not true, I shade where it isn't. But because it's true, I shade where it is. So it's over here. And if you plug it into Desmos, this is what you're going to get. It's going to look like this. Now, I know as I'm saying this, some of you are probably saying like, that really wasn't that fast. If you know these concepts really well, this can be the faster way. If this isn't something that you have a lot of experience with, I can't quite get those zeros here. I'm just going to leave them. If this isn't something you have a lot of experience with and you don't think that you can do this quickly, by all means, just, put it into Desmos. The goal is we want you to have this concept that it has to be in this double shaded area, the area where they overlap, that is my winner. That is my place I need to look for. It's in this double shaded area. That's the key takeaway. However you decide or figure out where this double shaded area is, either by doing a quick little sketch and going like, okay, it's going to be right there, or putting in Desmos, whatever works best for you is the way you should use. But this is the knowledge right here, that it's the overlapping area, the double shaded, and that one of these points has to be in that area for it to be an answer, to be a solution. So let's look at each one of these points one by one. First, we have -14, 0. So -14 heading out this way, -14, no. As soon as I head past this like negative half, it's out of the black area here. It's out of this double shaded. It's not an answer. It may be in the green. It's not. But, just that if I did a quick sketch of this, I'm saying if I didn't draw it to scale, if I just did a very quick sketch, then I still would be able to see, like, no, it might be in the green, it might be out here, but it's definitely not in this black. I don't need to do any further checking, even if it's a quick doodle. So A is out. Then we have 0, -14. So 0, -14. Nope, anything below -1 is out. I know that's where the y-intercept is. Nope, that one is out. Then I have 0, 14. That's going to be way up here. Nope, anything above 7 on the x-axis is out because that's that y-intercept there. So that one is done. Then 14, 0, like, yes, out here, this is definitely going to be, as this expands and gets bigger and bigger, 14, 0, it's definitely going to be in that shaded area. So again, your mileage may vary as to which of these is easier. Please just use what makes more sense. But I want the big takeaway to be, you want it to be in the area of overlap in those two inequalities. That's where your solution is going to lie. Hey guys, if this was helpful or useful in any way, please let YouTube know so I can keep helping you and others like you. Comment, like, share, subscribe, you know the drill. Also, if you're interested in practical or fun math-related items like this math clock or this hopefully humorous t-shirt, click on the links down below to check out my Spreadshop and Etsy stores. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.